Welcome back for the Troubleshooting View lesson of the VMware View 5 Essentials training. In this lesson, we'll deal with how to troubleshoot View. In this lesson, we'll cover how to troubleshoot View, starting by going through some of the common failure points where View can break down on you. In order to help you best troubleshoot View, you first need to understand the procedure that View will go through to connect a user to their desktop. So I'll walk you through those steps. We'll then discuss how linked clones work, followed by a listing of the ports needed for View connectivity. We'll then go over some ways that you can tweak the performance of PC over IP. Then we'll finish up by going over the locations of some log files and how you can collect further diagnostic information from View. And then we'll finish up with some walkthroughs on how to troubleshoot View issues. So let's start with the common failure points. Network connectivity is probably the most common issue you'll run into, and most of your standard connectivity troubleshooting will apply here. Checking stuff like proxy and firewall settings, and checking to make sure DNS resolution works. This can be as simple as from the client device, connecting to the View connection server website. The simple way to test this is to load up a browser on the client device, and try to connect to the security or connection server. If that all works, then you can use Telnet to check the other ports that we'll talk about later in this lesson, to make sure that you can connect from the client to the server into the desktop, to make sure you can properly connect from the View client machine to the connection server or security server. There are some instances in which you may need to configure the IP address in the external URL field within VMware View for either the connection server or the security server, or possibly both. This could be in instances where DNS resolution may not be available. You may also need to go in, when using a security server, you'll need to make sure to enable the PC over IP secure gateway functionality and set the proper PC over IP external URL. Otherwise, the security server may not pass through PC over IP connections, or may be forcing the View client to connect to an internal URL rather than the external URL they'll need to hit, rather than the external URL that they'll need to use. When you run into network connectivity between the desktop and the connection server, you'll usually see issues within View Administrator where the status for the desktop can't be updated. This oftentimes manifests itself as an agent unavailable message. This often shows up as an agent unavailable status for the desktop. Again, you'll want to check your proxy and firewall settings and DNS resolution between the desktop and the connection server. You'll also want to make sure that the desktop has a valid DHCP IP address. With the number of desktops that View can spin up and down in a short period of time, it's not unusual for a DHCP scope to be used up fairly quickly. If you see this type of issue, you may need to set your DHCP lease times to a lower value to ensure that they clean up a lot quicker. When a pool fails to create, you'll first want to make sure the vCenter web service is available and that the connection server can connect to it. This is the primary method of manipulating the pools and the desktops within it. Also check to make sure that there's enough free space on the data store that you configured for the pool. If there's not enough free space on the data store that you've configured the pool to use, no desktops will be able to be created. If those infrastructure pieces still look good, you'll want to double check the permissions that have been granted to the View and View Composer accounts that you used within the vCenter configuration of View Administrator, making sure that it can properly access all pieces of the vSphere infrastructure that are needed to create the pool. You'll also need to make sure that the Active Directory permissions are correct as well, because not having the proper permissions in AD can cause provisioning to fail. If you're running into a resource constraint on your vCenter server, you may need to reduce the maximum number of concurrent provisioning and power operations within the View Administrator console. This can be done within the vCenter settings in View. You may also need to consider adding additional vCenter servers if your View environment is growing too big for a single vCenter server. If you find VMs that get stuck in a provisioning state, this is likely due to a restart of the connection server. If a connection server restarts during the deployment of a virtual machine, that virtual machine can get lost. You'll simply need to delete that virtual machine and then allow View to redeploy a desktop in its place. If you find VM stuck in a customizing state, it's likely that this could be due to a data store that has filled up and doesn't leave enough space for the VM to power on. Remember, each VM by default is going to try and store its swap file the same size as the space that the virtual machine is configured with, and that swap file will be located on the same data store as the VM. So make sure it's got enough space to do that. If you have problems with USB redirection, I'd highly recommend to make sure that you're using PC over IP instead of RDP, since PC over IP can better handle different USB devices. Next, you'll want to check to make sure that the policies within View for the global, pool, and individual user levels all have USB redirection enabled, which it should be by default. Next, you can check the logs on both the virtual desktop and the end user device for entries containing WSSM_USB or WSWC_USB, which will indicate log messages related to USB redirection. Then the virtual desktop, you'll also want to make sure that the VMware View Virtual USB Device Manager and the VMware View Virtual USB Hub drivers are installed properly and haven't been disabled. These can be re-enabled by reinstalling the View service. If there are issues there, you can simply rerun the View Agent installer, and that should properly configure them. You also want to check the client device if it's a Windows machine to make sure that the VMware View generic USB device driver and the USB driver for that specific device are both installed and enabled. These are critical to being able to redirect across the PC over IP connection. As with any IT asset, troubleshooting is based on experience with the product and understanding how it works. So let's talk about the procedure that View goes through in order to connect a user to a desktop. First of all, the View client is going to initiate a connection to the connection server or security server, providing a username and password. This occurs over port 443, which is your standard HTTPS port. Next, the connection server will return a list of entitled desktops that the user has, and the user will then select one, sending that information back to the connection server. Again, this occurs over port 443. Next, the View client will initiate the PC over IP connection to the desktop. This will occur over TCP port 4172. After that, the View client on the client device and the View agent in the virtual desktop will negotiate the PC over IP session. This happens over several back and forth communications over TCP port 4172. Once the session has been negotiated, the agent will initiate a PC over IP data channel connection directly to the View client. This will be over UDP port 4172. Once that initial connection is created, the control and data sessions will be opened up between the client and agent, again over UDP port 4172. At this point, a connection to the desktop has been made. While the PC over IP connection over UDP port 4172 is going on, PC over IP will also open up a heartbeat connection between the client and the agent using TCP port 4172. The client will also open up a heartbeat between the client and the connection server over port 443. This is so that the connection server and View administrator have some awareness of the session. Let's also go over how linked clones work, so you can be better prepared for troubleshooting issues with your Composer-based pools. So all linked clone desktops link back to a specific replica VM. This is not the actual parent VM, which is an important distinction to make. View does this so that the individual linked clones aren't dependent on the parent VM. So changes can be made to the parent VM while the clones are in operation. This replica VM is a protected entity within vCenter, preventing you from making any modifications to it, and thereby preventing any potential issues with the linked clones. The replica itself is a thin provisioned full clone of the parent VM at the specific snapshot that was chosen to be the base image. As soon as you create a pool, or recompose a pool and tell it to use a specific snapshot on a specific parent VM, as soon as you create the pool, or recompose a pool, View will initiate a full clone of that snapshot state. By default, if you don't choose a specific data store to store the replica machines on, one replica will be created for each data store that pool is defined to use. So you will have multiple copies of that parent image's snapshot across all your data stores, unless you choose to put all your replicas on a single data store. Now to save space, View will actually utilize replicas between pools that are using the same parent VM and same snapshot state. This also greatly speeds up the process of deploying a new pool, because on subsequent pools that use the same base image, you save the time of having to create that full clone replica of the parent VM. Now occasionally replicas can be orphaned and will need to be manually deleted from vCenter. In order to see the replicas within vCenter, which are hidden by default, you'll need to go into the client settings for the vSphere client and enable the Show View Composer Virtual Machine setting. which will then present a new folder under which you'll find all of your replica VMs. Those replicas will still be protected entities, so you won't be able to do anything with them. So in order to delete replicas, you can use the SVI config utility to unprotect all of the replicas. You can see this command on the screen now. So what different ports do you need to make sure to have open within the firewall? Well, first of all, you'll need to make sure TCP ports 80 and 443 are open between the client and also between the security server, the transfer server, and also between the security server and transfer server, and the connection server and the vCenter server. Port 8009 will need to be open between the security server and the connection server. Port 4001 will also need to be open between the security server and the connection server, as well as the virtual desktops and the connection server. When using RDP as the connection protocol, you'll need to make sure that between the security server and the virtual desktop, the ports 3389, 32111, and 9427 are all opened, to provide all the proper data communication. When using PC over IP, you'll need to make sure that TCP port 4172 and 32111 are both open between the client and the connection or security server and the desktop. UDP port 4172 will also need to be open for bidirectional communication between the client and connection server or security server, and also between the security server, connection server, and the virtual desktop. Finally, port 4100 will need to be open between all connection servers. This usually isn't a problem because you want to keep all connection servers on the same subnet. Because of the replication of LDAP between them, this needs to be a high-speed connection. So now let's talk about some of the tweaks you can make to improve PC over IP performance. First of all, remember that PC over IP is a self-adapting protocol, which will automatically manage bandwidth. So only tweak PC over IP when it is absolutely necessary. In other words, when you see problems. Before you tweak PC over IP, I highly recommend reducing the effects and animations within your parent VM. This would include disabling arrow effects and themes within Windows. It'll make the Windows interface less pretty, but more responsive. Before you go too far tweaking any settings of PC over IP, make sure you review the logs first, because this will reveal some of the information that you'll need to determine which settings to tweak. View provides an ADM template for tweaking PC over IP, which is the preferred way of doing it. These settings can be tweaked directly in the registry of the parent VM, but utilizing group policy is generally going to be an easier way to do it. This list represents the main settings that you'll want to tweak for PC over IP performance, but is by no means exhaustive of all the settings that are available. If you're running into bandwidth constraints, two of the quickest ones to modify could be your max bandwidth and your bandwidth floor, which represents the maximum and minimum bandwidth that will be given to PC over IP. Also take a look at the MTU size, which you can use to enable jumbo frames. But be careful because setting up jumbo frames could cause fragmentation in a lot of situations, especially connections going through the security server that are going across the public internet that may not support jumbo frames. You can also explicitly limit the bandwidth that audio is given, which will decrease the quality of the audio, but hopefully free up bandwidth for the user interface. You can also set the minimum image quality. By reducing this value, you can create higher frame rates, but at the cost of having lower quality images. You can also set the max initial image quality. By lowering this value, the initial images that are displayed will be lower quality, but will also require less bandwidth to get an initial image to the client. You can reduce the maximum frame rate that PC over IP will provide, which of course will reduce the bandwidth needs. A new feature with View 5 is the ability to turn off the build to lossless feature. By default, PC over IP is going to continue sending progressively more improved images to the client device until it gets to a completely lossless image. In a low bandwidth environment, you may want to enable this setting in order to prevent PC over IP from building the screen to a completely lossless image. It will reduce and lower quality, but will ultimately use less bandwidth. The setting will probably be okay to enable on most desktops, but anything that requires a high resolution, like an X-ray image, will definitely suffer when using this setting. Finally, you can modify the encryption algorithm that PC over IP will use to encrypt the PC over IP packets. By default, both the SALSA 20 and AES 128 algorithms are enabled, and which one is used will be negotiated between the client and the agent. For low bandwidth situations, VMware recommends using the SALSA 20 only, which is a faster algorithm. Of course, no troubleshooting course would be complete without identifying where the log files are at. So for your agent, connection server, security server, and transfer servers, you can look in either the Documents and Settings or Program Data directory, depending on whether the operating system is Windows XP or Windows 2003, or Windows 2008 and Windows 7. In either case, they're in the directory called VMware/VDM/logs. On the client side, you'll look in the User's Application Data directory, under VMware VDM logs. On the vCenter server, you can find the Composer logs under the All Users directory, under the All Users Application area on Windows 2003, or under Users All Users on Windows 2008 servers. From there, both go under the VMware directory View Composer logs. Finally, if you can't figure out the issue, you're going to have to open a ticket with VMware. Before you do that, VMware recommends you collect the diagnostic information before opening the case. This will create an information bundle that will aid them in their troubleshooting efforts. The procedure for creating this bundle depends on the component that we're talking about. For the View agent, you'll want to run the VDM admin command on the View connection server, which will automatically contact the View agent and pull down the information it needs. You'll simply need to identify the pool, the specific desktop within the pool, tell it to get the DCT, and then identify the output file that you want to place it in. When in the View client, you can click on the Options button and select the support information. This gives you the ability to collect a support data bundle. A command window will then pop up showing the progress of the collection, and there will be some questions it'll ask, so provide those when you're prompted. On your vCenter server, to collect diagnostic information for View Composer, you'll have to go under the Program Files for View Composer in a command prompt and execute cscript utilizing the svi support.wsf command with a /zip flag. On the connection server, you'll first need to set the proper level of logging that you want to collect, complete any task that happens to be failing, and then you'll be able to generate the log file bundle using a Start Menu program. Finally, you can use the support.bat file that can be found in the DCT directory in the installation location for the agent, client, and connection servers. Now let's take a look at some real-world examples of problem desktops. Let's start here on the Problem Desktops view within the View Administrator. This can be reached by clicking on the Desktops inventory, then clicking on Problem Desktops, or by clicking Problem Desktops in the top left navigation area. Either way, you'll be presented with a list of desktops that are in a status that is considered problem. In this case, you can see there are 3 different desktops with 3 different errors. The first one is an agent unreachable, the second is an unassigned user, and the third is an error state. It states that the View Composer agent initialization state errored, and that it had a failure to join the domain. Let's start with that one, and we'll see if we can figure out what's wrong with it. This was the Accounting 02 desktop. So let's switch over to our vSphere client and take a look. Looking at the general information for the Accounting 02 machine, we can see that the IP address is set to 0.0.0.0, indicating that there may not be a network connection. Let's start there. Checking the network adapter, we can see that it is connected and it's supposed to connect at power on, so that should be good. Next, let's log into the machine and take a look. We'll go ahead and log in. We'll open up a command prompt and run an ipconfig. where we can see it truly does have a 0.0.0.0 address. My suspicion here is that DHCP couldn't be contacted or couldn't provide an IP address. Let's try and renew the IP address with DHCP and see if we can get an address that way. And now we can see that we did gain an IP address. Most likely what we need to do with our DHCP scope is to reduce the lease time so that the IP address of machines that are deleted will be returned back to the pool quicker, so they can be provided to new virtual machines. Let's double check to make sure everything's okay by refreshing the View Administrator. Since this virtual machine has completely errored out during the provisioning process, we're going to need to actually delete the virtual machine and create a new one. But now we know why this one errored out, and hopefully the next one will be able to connect and get a DHCP address. So we'll simply come in here, select the Accounting 02 machine, and click the Remove button. Since the accounting pool is a floating pool, backed by View Composer, deleting the virtual machine should be able to quickly recreate a new one in its place, without affecting any users. And now refreshing shows that that machine is no longer a problem desktop. The new accounting machine that comes up should come up without any errors. Next, let's take a look at Agents 03, which is currently in a status of an unassigned user connected. Since the Agents pool is a dedicated pool, Charles has been assigned to the Agents 03 desktop, and no one else should be able to log into it. But it looks like someone other than Charles has been connected to it. The most likely place for this to happen is when an administrator logs in through the vSphere client. So let's start there. As we can see, I have apparently logged into this machine already through the vSphere client. I'll simply log myself off here, which should free it up so that Charles can log in through View. Refreshing our Problem Desktops view will now show that Agents 03 is no longer Problem Desktop and is available for Charles to log in. Next, let's move on to Call Center 02 and take a look at its Agent Unreachable. There are several things that could cause the agent to be unreachable. Network connectivity is one possibility. The service not starting is another one. Either way, let's log into Call Center 02. Let's start by pinging our View server and make sure that we can still talk to it. Clearly, network connectivity is working from this virtual machine to the View server. Let's take a look at the next possibility, which is that the service for some reason didn't start properly. And here we can see that the View agent has not started. So let's manually start this. And we can go back into View Administrator and verify that it can speak to the agent now. And now we can see it's no longer a problem desktop, meaning it must have talked into the View agent. Showing all of our desktops, we can now see that everything is either connected, available, provisioned, or disconnected. Now we want to make sure that we log out of our Call Center 02 machine. So that it's free for other users to use. So that's a quick look on how to troubleshoot some of the most common problem desktop errors. Of course, with any application that contains multiple tiers like View, there could be multiple different things that could cause problems, or different types of problems that may manifest. But that quick look should show you the most common things to look for. Now, I'd like to show you what linked clones look like within the vSphere infrastructure. Understanding how linked clones work will help you troubleshoot any issues you may have in your View Composer-based pools. Linked clones are based on a replica VM that represents the parent VM image. In order to understand that replica, we'll need to be able to see it. By default in the vSphere client, you won't be able to see the replicas. In order to see these replicas, we're going to need to go into the client settings to enable being able to view them. By checking the Show View Composer Virtual Machines checkbox here, the vSphere client will show us the view replicas. Now you can see there's a VMware View Composer Replicas folder that has appeared, and inside of there are 4 different replica files. These replicas are normal virtual machines. They're not templates or anything special there. But they are locked, so we don't have the ability to delete them, to change any of their settings, or to perform any power operations. This is so that the replicas cannot be modified while linked clones are using them. The last thing you want to do is accidentally delete one of these replicas and have it be the base of one of your desktop pools, thereby rendering those desktops completely unusable. Occasionally, View and Composer will mess up the connections with the replicas and may not properly delete one of the replicas when we delete a pool, or recompose a pool to use a completely different image. In that case, you will have to go in and manually delete a replica. In order to enable this, so to unprotect these replicas, we'll need to go to the command line and use the SVI config tool. The SVI config tool is located in the Program Files directory for View Composer, so we'll start off by changing directory there. In here you can see the sviconfig.exe tool. That's the utility that we want to use here. We'll start off by defining the operation, which is unprotect entity. Next we need to define the URL for our vCenter server. Then we need to define the username that we'll use to connect to vCenter, followed by the password for that account. Then we need to define where our replicas are stored. That's this VMware View Composer Replicas folder that we see back in the vSphere client. The path starts off with a home directory, followed by a VM directory, and ending with the VMware View Composer Replica folder. Finally, we'll tell it to recursively unlock all of the replicas that exist within that inventory path by setting the recursive flag to true. And now we've successfully unprotected all of our replicas. If we come back into the vSphere client, we can see we now have the option to delete, remove from inventory, edit settings, and provide a power on operation. This will be true for all the replicas. In order to re-protect our replicas, we'll simply run the same command, but we'll change the operation to protect entity. And now we've successfully protected all of the same entities. Back in the vSphere client, we can validate this by seeing that our settings and delete from disk and power operations are no longer available to us. Next, let's take a look at one of our vDesktops and take a look at the snapshot that exists on it. Next, let's take a look at one of our virtual desktops. Next, I'd like to show you one of the vDesktops and take a look at a snapshot that View automatically creates for use with refresh operations. Here you can see that there's a VDM initial checkpoint snapshot that's been taken, which the description clearly states is used to revert the OS disk. When doing a refresh operation, View will revert the snapshot of the virtual machine to this initial checkpoint snapshot. This eliminates all changes that have been made to the virtual desktop from the time that the configure task was completed to the current state. The advantage of this is that you don't have to go through the whole customization process all over again, because we can go back to a state immediately after the customization by simply reverting the snapshot. Now that you have a better understanding of how linked clones work, hopefully you'll be able to feel comfortable troubleshooting them as well. Now, View is like any other system out there. It takes some experience and some good documentation to help you troubleshoot it. To that end, I've included some of the best documentation out for troubleshooting View. First of all, the VMware Knowledge Base, which contains a listing of all the issues that VMware's discovered with their products. There's tons of stuff out there, so I highly recommend you take a look at that. Searching Google will usually find a good knowledge base article, but sometimes you gotta craft the query just right. Oftentimes, you'll also come up with some really good results out of VMware's community site as well. Next is the VMware View resolution paths, which will help guide you through the troubleshooting process to figure out which KBs may apply and other documents that may be useful. You may also want to take a look at the VMware View resolution paths. This is a document that VMware support has put together to help customers to be able to narrow down where the issue may be and help guide you to a particular knowledge base article that may be useful. The View Administration Guide should always be in your tool belt anytime you're troubleshooting. It's by far the most thorough single document out there for VMware View and all the components within it. Finally, the View Architecture Planning Guide can help out with understanding how the components are supposed to fit together and contains useful information about the ports needed between the different components and many other items. So let's wrap up with a quick review. We started off talking about some of the common failure points that a View infrastructure may run into. Everything from network connectivity to common issues that you'll see with the virtual desktops themselves and creating the virtual desktops. Then we talked about the connection procedure in order to help you understand what steps are taken during the connection to a vDesktop. Then we talked about how linked clones work, specifically to help you understand what the different components are under the covers, and how to pull the covers back in order to make modifications when necessary. And I give you a listing of all the ports needed for the different components of View, so that you can know which firewall ports may need to be open, and the type of traffic that goes on back and forth. Then we talked about the performance of PC over IP, and what you can do to tweak that performance, and to make it better depending on the network infrastructure you have. I then gave you a listing of all the log locations, so that when you're troubleshooting, you can go straight to those logs and be able to pull out information about what's going on in the environment. To go along with the logs, you may also need to collect diagnostic information, specifically when calling VMware support. They're going to want to know some information about your environment, and these diagnostic bundles will help you gather that information and provide it to them in a quick and easy format. And finally, I did a couple of walkthroughs of the environment, showing you both how to troubleshoot problem desktops and what linked clones actually look like within a vSphere environment. So hopefully all this information will be useful to you. This is of course just a starting point for how to troubleshoot, but hopefully this is enough to get you in the door and started.